Hi, I'm Darren Meyer. I'm the lead solution architect for Endor Labs, and today I'm going to be talking to you about the requirements phase of the software development lifecycle and how we're going to look at open source dependency management in that context. Now, very much like the planning phase, the requirements phase used to be very waterfall-y. It used to be a lot of effort up front to try to maximally specify everything that we could about software so we understand before we begin writing even a single line of code what all of our requirements were. And in some ways, this made the application security team's job a little bit easy. We could specify security requirements. We could have them as a checklist. We could write test cases against them. We could do all of these things, and everybody could sign a requirements document that says we are going to have these security controls. We're going to operate this way. Here are the rules. This is the design, and so on. But that's not how modern software development works. We figured out a long time ago that kind of upfront requirements planning doesn't make sense for most types of software projects. And we've replaced it with things like Agile and Lean, where the requirements are embraced as a changing thing, right? So that every time software is being released, it creates a feedback loop where we're getting new requirements from testers, from customers, from developers who are using it, to basically everybody who interacts with it. We're pulling new requirements in, we're modifying requirements, we're making decisions about whether requirements were met on these very short time cycles, a sprint at longest, typically. And we're just expecting the requirements to change. So doing a big requirements gathering thing up front isn't really helpful in that model. So this has made the AppSec job a little bit harder in that we don't have the staff or the capabilities to be in every single requirements conversation because they are ongoing and perpetual, right? We would have to have 10 times the size. So there's a couple different approaches to this, and one is very much like we talked in planning of setting up kind of preset requirements documents, things like standards, things like baselines that people can follow, that this is a standard set. And it can come down into, you will use this service for this purpose unless you get an exception of some kind, but you have to prove that you have a business case that justifies it. That's great. You can apply that to open source dependencies by saying any open source dependency you select has to meet these criteria. You have to have automated tools that help you enforce that because there is no way that kind of requirements enforcement scales with just people. And once your organization gets to a certain size, once your applications get to a certain size, you can't slow your development teams down by having them wait 2, 3, 4 days from I want to use this dependency to AppSec saying yes or no, that's okay, right? So you need to figure out some automated tools and some self-service for developers so that the vast majority of the time they know and understand the policies and standards, and they have the tools to help them, make go, no-go decisions. But there's also the evolving requirements bit, right? So you can set those baselines and those standards, and you can put enforcement controls in place to make sure that people know when they're about to run afoul of them. But it's not going to really embrace the changing requirements and the kind of very detailed things that evolve. People could pick a dependency today, and 3 days from now, there are 4 critical CVEs in it. So there's a little bit of requirements pathway that's comes down to like, how are we going to manage that? Are we going to set very clear, technologically enforceable rules that say, hey, when there's an issue that we can detect, whether it's a licensing issue or an operational risk issue or CVE or malware detector, whatever the case may be, think through what are those capabilities and what are those cases that could arise that we can detect and surface, and how are we going to react to them? When do we need a developer to take a predefined action, and when do we need no action, and when do we need a security professional to make a determination and give some level of human review and context to those things? So things to consider in that are severity, of course, the CVSS score of something like a vulnerability or a particular operational risk, like how big of a deal is it if someone selects a dependency that's unmaintained, right? Is there an option to vendor it in where we're saying, okay, that's unmaintained, but we have the source code, we're going to take on maintenance of it? What are the rules for that, right? And there has to be a fast path to not only assess those pre-existing standards through some kind of technical control, so that when a developer is saying, oh, hey, I need to choose this dependency to accomplish this goal, right? I need to have a JDBC pool, I'm going to choose C3PO, right? They need to be able to go and look at it and go, okay, this doesn't seem well maintained. This is just a single person's repo. This maybe has a critical vulnerability that's unpatched. What are my rules for saying this is an okay choice? But then also, what if I want to use something that's borderline? How do I approach that? What's the exception path look like? So there's some of those system design requirements that you have to put in place so that as the requirements of the application and your end users and customers change, that you don't just have these rigid rules that say you can never have a thing with a vulnerability in it. What if I'm not using the vulnerable part? Does that rule still apply? What if I can mitigate the effect of that vulnerability through a design choice or through a compensating control and operations? How do I go get those approvals? How do I make a business case to break the rules? How do I embrace those changing requirements? And really what it comes down to is the ability to be able to constantly assess and review every change to the software that's being made. So every time that something approaches a deployment, whether that's into an integration environment or whether it's deployment to customers, there's a lot of business like decision stuff that has to happen here in terms of what program is sustainable for you at your level of maturity. But you need to be able to automatically test those things against the policies that you've set and say, okay, we've surfaced risks. What are we going to ask you to do about those risks? When are we going to say, hey, your requirement has to change? You can no longer use that. You have to use something else. When are we going to say, oh, your requirements have changed incoming, so we're going to let you do something we weren't going to let you do before because something about the environment, the world, the application, the customer needs have changed. So it's very important to do the program design work for a dependency management program to start to understand how are software requirements likely to change in general? What's the process for that? And how do we apply a process and a security control regime that doesn't slow down developers? You can't be zero delay, but what you want is a delay to shipping new features and shipping bug fixes to be very manageable and very short. And so the value that your program is delivering is more than worth the delay that it causes.